Now, given all the discussion that we have had today, and I wish we had more discussions. So it's already 6:10. So let's have. I'm open to having some questions from you. I'm looking forward to that. And one more quick note before we get into the general discussion, which is there are a few topics that are still left. I wish I could cover those very clearly and rigorously, like chi-square test, t-test, variations of t-test like Welch test. We will set up a public live session, hopefully, public live session in the future to cover those. Again, somebody is asking about upper bounding techniques like UCB. Yes, UCB also works better than Thompson sampling, but it's slightly trickier to explain that, right? So as I told you, multi-arm bandits is a slightly advanced topic, but it's easy to get our head around. Some of those concepts require understanding of machine learning, which everybody may not have. Okay, so let me go into Q&A quickly. Okay, so this question is, does applied roots cover all the statistical concepts? So again, we can spend 5 years covering just statistics. So what we try to do in all of our courses is to pick those concepts that are most widely used in the industry. So it's impossible to cover everything, but we cover a good chunk of it. Like even from today's sessions, I think we cover about 50% of them in our course. Others will add them as optional topics because nobody knows everything on day zero, right? So we cover almost 90 to 95% of concepts that are relevant in the industry. I think closer to 95%. And again, we'll keep adding optional content for folks through live sessions like these. Can we share some links or blogs for missed topics? Very nice. So Parthosh, I actually, okay, so let's do one thing. I'll add that and we'll send you the emails most likely tomorrow about the notes and code and things like that. Because my notes is still little messed up. I try to edit a little because of constraints of time. During the lunch break, I was editing the notes because I had to remove some parts from t-test and things like that. So just give us a day or so. We will share the notes to the email addresses that you've given when you registered for this. Okay. Okay, so cool. Again, for some of the concepts like t-test and chi-square test, I'll provide you some simple to understand references. Okay. Okay. So I'm just clicking on all those which have been there. Okay. This is a request to add dark theme to applied roots. Yeah, we are already working on it. We just need to get all the graphic work done ready. So that's something that we're looking at. Anyway, that's a very good suggestion. Okay. Somebody is suggesting me to create a poll. Okay. So let's do a poll. Anyway, this is good. The good time, right? So what format do I have the previous poll? I don't know. I don't have it. I think I'll have to clear it. 1 second. I think I asked this in the first session, right? Okay. Show on stage. 1 second. How do I restart the poll? Just a second, please. Close poll. Okay. I don't think. Okay. I'll have to redo this. Okay. I'll redo it. Don't worry. I'll just do a quick redo because it's a good suggestion that somebody made. I'll also take your question. Just give me a second, please. Session 4, create a poll. 1 day, 7 hours, or 2 days, 4 hours per day, or 4 days, 2 hours per day. I think these are that's all I had. So save draft and I'm just publishing it. Just give me a second. I'll show it to you on stage. All the numbers are changing. Okay. So anyway, while you do that, I'll also take some general questions. Okay. I'm just looking at all the questions that are here and trying to answer as many as possible. So nice question from Lavi. So the question here is, till now we have taken the null hypothesis as that x is same as y or x is not equal to y. Can we take if x is less than y or x is greater than y as null hypothesis? You can do that theoretically, But in the context of something like permutation testing, it might be a little tricky. That's why a lot of statistical tests don't have that, because if you take that as a null hypothesis, constructing the distribution of the test statistic or estimating the distribution of the test statistic or doing the simulations is very hard, right? But if you want to say, hey, is x greater than y or x less than y, that is doable. But even there, the null hypothesis will be, is x equal to y, right? If you have two random variables, and the alternative hypothesis is x greater than y. That's the alternative hypothesis. You can do that as an alternative hypothesis, not as a null hypothesis. Okay, so let's look at this. Okay, I think the statistics have changed quite a lot. I think 57% of people want 2 days, 4 hours per day. And okay, and about 29% of folks want 1 day, 7 hours. Good. And 14% want 4 days, 2 hours. Cool, very nice. Thank you for participating. Just it's good to have this data with us so that we can plan things accordingly in the future in case we do some of these long form sessions. Cool. Very good. So okay, I'm just signing off all the questions. Okay. Very nice question. So Praveen says, slightly off topic, but just wanted to understand how exactly we use these testing in EDA, in exploratory data analysis part of machine learning. Okay. Yeah, you can do this for individual variables, as you rightly suggested, right? So for example, can you say, again, don't always think that it has to be done only from an EDA perspective. In the EDA perspective, you can say, hey, are these two random variables related in any way? Do they have the same distribution? Or is, if you have x and y, right, is there a correlation between x and y? Okay, that's something, because using permutation testing, you can compute correlation coefficients also, right? There's nothing that's stopping you from doing that. So you can do similar concept of hypothesis testing in a permutation testing type of setup for the application of for people for primarily detecting if two things are correlated or not. I remember a very nice question that I saw in the half an hour break at 4:30, which is, what is the difference between K-S test and Mann-Whitney U? That's a very good question. So typically, I mean, empirically, you can also prove that rigorously. So K-S test is going to plot the CDF of the random variables, and it's going to look at the gap between the CDF. That's the idea, right? For those of you who know K-S test. Now, K-S test can find differences between distributions, even if the distributions have the same central behavior, but their variances are different. Imagine if I have two distributions, one distribution like this, other distribution also like this. So the mean and median are roughly the same, but their variances are different. For such distributions, if you have small samples, K-S test typically tends to work better, because the Mann-Whitney U tries to compare every pair of values. So if the medians of both of them are same, for small samples, Mann-Whitney U may give you a type of one of the errors, right? So the simple logic here is, if you have two distributions that you're comparing, if the two distributions have a similar mean or a similar median, similar central behavior, Mann-Whitney U can make errors, while K-S test has a lower probability of making errors, number one. Number two is, the K-S test can find, because it's literally plotting two CDFs and trying to find the gaps. So if there is any difference in the distributions, it will find. While, because this is like a rank pair test, right, where between every pair or rank sign test, it's comparing all the pairs, it is less likely to work in the extreme cases. I'm not saying all the cases, but in some extreme cases, and that's important. Okay, cool. If my confidence interval lies outside the median calculated before, it will not happen, right? Most likely it won't happen. Again, there might be some extreme situation where that might happen, but I can't think of anything at the top of my mind. I can't think of any distribution for which that will happen. Quickly, I can't think at the top of my mind. Okay, so this is a question about regarding significance or alpha value. If it is 5%, does it mean 5% is allowed in our results? No, 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 no. Please don't mix that. Alpha value of 5% basically means that that your p value, the probability value that you computed, you're willing to accept or you're willing to reject the null hypothesis till the time that p value is up to the significance level. The statement that you said is, which is not correct, is not rightly framed. So just because your alpha or significance level is 5% does not mean that we are allowing 5% of our errors in our results. No, that's not what it means. How do we figure p-value in Mann-Whitney? It's very simple, right? In Mann-Whitney, your U follows a normal distribution. Normal distribution has a very well-defined mathematical equation for its PDF and CDF. So once you have an observed U, you say how much area is there in this region. Again, you can get it very easily because if you remember, PDF has an exponential form and when you have a curve, you can compute the area under the curve using integration. If you remember that from your 11th and 12th class mathematics, that's how it's actually done, using something called as a trapezoidal rule for integration. Okay, sounds good. So, okay, I'm handing the mic to Kameshwaran.
Good evening.
Hey.
I had a couple of questions. The first one is a generic question with regards to how the job is in the data science and ML space. That is, today we spoke about A/B testing and the different concepts surrounding it. And there is also the machine learning part where you have deep learning, supervised learning, etc. Now, in a typical role of a data scientist or a person who is working in the data science role, what is the split in terms of A/B testing versus the ML?
It's very hard to say that because it all depends on the team that you're working in and the maturity of the team that you're working in. Like there are some teams, for example, I'll give you some my personal experiences. If you work at a team like Amazon's retail or recommendation systems, right? Those are very mature teams. They have like world-class economists and statisticians that have built their A/B testing platform where we don't have to worry about it. While in my organization, I worked with a bunch of very good statisticians from my team to design the first cut version of A/B testing platform. So we had to design some of it and we had no clue how to do it. Thankfully, we had great guidance from phenomenal economists and statisticians in other organizations of Amazon who held our hand and helped us. So it depends a lot on the org that you are in and at the time. Like there were months where I was just completely working on A/B testing platform design. There were months where I was doing complete hardcore deep learning on internet scale data, right?
Okay.
So it varies a lot. It depends a lot on the context. So my suggestion in terms of learning is have the breadth of knowledge. You may not have the depth of knowledge in everything. Again, we didn't go too deep in today's exercise, but it's always good to have the breadth of knowledge and continuously learn because you don't know tomorrow you might be asked to design a multi-arm bandit solution for some company, right? So it's very hard to pinpoint and say 10% you'll do that because imagine if you fall in the team which builds the A/B testing platform, 90% of your time goes into that, right? So it
Yeah.
depends a lot on the team and the organization that you're working for.
Okay. The other question was regarding epsilon greedy. What is the exit criteria for the epsilon greedy or the Thompson sampling algorithm?
So
That is, when do we decide, okay,
yes.
this is
So,
the...
very nice question. So there is an exit strategy, again, which comes from reinforcement learning. If we know that after experimenting for a while, if you're very certain, again, I'll give a simple strategy for epsilon greedy, right? We have these CTRs, right? We can compute the confidence interval on the click-through rates. Again, using the same strategies that we employed, which is bootstrap samples, right?
Right.
We can compute these confidence intervals, and when the confidence interval become tight enough, right?
Okay.
Let's assume I have four thumbnails, 1, 2, 3, 4, and I have the CTRs and I have the confidence intervals around them. And the confidence intervals have become tight enough, and I know that T3 is consistently better than T1, T2, T4. I just throw T1, T2, T4 outside and just continue with only the winner, which is T3.
Okay.
Or I keep T3, I leave T1, T2, T4, introduce T5, T6, T7, T7 to run my epsilon gradient.
Okay. Okay. The last question, or rather,
Please.
input is something that I observed in the chat window. We started with 700 and plus users, and in the afternoon session we had around 400 plus, and now we have 300. So probably 4 hours in the weekend probably would be a good idea, I believe.
No, that's a very valid point. Very
Yeah.
valid point. Actually, I've been looking at this number just now, and I agree that people will get exhausted. That's only human and natural. And teaching it is easier for me, to be honest, because I'm just talking and I just have a lot of coffee and tea. But the problem is digesting these concepts, absorbing everything is actually much harder because you have to think in that process. In my case, thankfully, I know some of this, I've learned it over the decades, and I just have to tell you and probably be little thoughtful when I'm explaining it. Apart from a little bit of aching on the throat, it's not too much conceptually hard for me. But for students, I completely understand that it could be challenging to digest anything more than 4 hours in a single sitting. I understand that. Very good point.
Thanks a lot, and really, I mean, appreciate your efforts. I mean, all throughout the day, helping us understand all these topics, which was completely new to me. And I have to say that you explained it very well and very intuitive. Thanks a
Thank you
lot.
very much. Thank you. Thank you, Kameshwaram. Thank you. So handing the mic to Divyansh. Hello.
Yeah, am I audible, sir?
Yes, yes, Divyansh.
Yeah. Thank you so much, sir, for the session.
My
Sir,
pleasure.
my question was that in confidence intervals, I understood that how it is calculated but why does that work? That I couldn't understand.
Very
The
nice. Good question. Good question. So, in the absence of additional data, these 500 values of 500 values that we have for people who have taken remdesivir, we are again assuming that these 500 values are randomly sampled from the global population, right? Treating these 500 values as the population. That's what we are doing, right? You agree with me with that? Hello.
yes, yes, sir.
So, because we don't have any additional data, given the constrained data that we have, just taking these 500 values and looking at these 500 values as the total population and then resampling, again, it's not always perfect, right? Imagine if you had an alternative world where you can keep taking 500 samples from the larger population. Let's assume you can do that. There will be differences between that sort of sampling from the larger population versus bootstrapped sampling. But bootstrapped sampling itself, again, the theory behind it works only in some situations, not in all situations. There will be some difference between both, but in practice, as long as the 500 values are a representative sample of the broader population, and as long as you don't have too extreme values, it will work reasonably well. Because 500 is not very small number, right? Again, remember, instead of 500 values, if you only had 50 values or 10 values, then bootstrap sampling will not work. That's also important. The bootstrap sample requires a reasonable size. Again, that depends on the context. In this case, since we have 500 values, 500 value sample that we have is a reasonable representation of the broader population. Well, if I have only 20, right, not much. Then, if I have only a sample size of 20, even if I do bootstrapping, the confidence interval I get will be very error prone.
Right. Okay. Thank you, sir.
Cool, cool. Thank you. This is to Rahul. Rahul? Rahul, you're not audible. Can you increase the microphone gain?
Audible right now?
Yeah, you're little audible. Yes, please continue.
Okay. So actually, my question is that, for example, for a large scale of AI development, where we need to suggest that what is the best medicine for a particular disease. Say, for example, whether it's a COVID or anything, or influenza or whatever. So in that case, if we have to test our models, so what would be the best way if we have to take a very large sample? Will Bootstrap be the best one in terms of order of time complexity?
So just to get a little clarification here, are you testing on people or are you testing drugs to see which of them work for a medicine?
I'm going to test the drugs which is good for the people.
You're
We
testing
have a
on
lot of
people.
suggestions. There are a lot of prescribed by the doctors, and we took all the samples,
Okay.
and we have the data at the moment. So, which would be the best in that case?
So as long as you're testing each of these drugs or medicines on maybe let's say 100 people, I'm just making up a number, reasonable number, not too small like 20. As long as it is a few hundred, even 100 people, confidence interval based strategies work reasonably well in practice. Bootstrap based confidence intervals.
Okay.
There is one more catch there, which is if the 100 samples that you have obtained, right? If you know that they belong to a specific distribution, if you know that, then you can use instead of, because bootstrap samples is a completely non-parametric technique, right?
Yes,
So let's assume I'll give you a simple concrete example here. Okay, let's assume you have taken blood pressure readings, right?
Yes, sir.
Or let's say blood pressure readings or heart rate or glucose levels in blood, right? If you take those values and when you plot them, they look very similar to Gaussian distribution.
Yes, sir.
Right? Then that is a better strategy, because if you know that a physical system or a physical, like your heart rate or your respiration rate, if they follow a specific distribution, and if there is tons of research that shows that they follow it, and you can prove it rigorously using your 100 sample that it follows, then again, distributions are like implicit additional knowledge. And if you're confident that it specifically comes from the distribution, and if you can prove it using KS test or Anderson-Darling test, then you can go through that methodology to get the 95% confidence interval.
Okay, sir. Okay.
Cool.
Thank you so much, sir, for a nice session, sir.
Thank you.
Okay.
Mic to Hamid.
Hi, sir. Can you hear me?
Yes.
First of all, pleasure to talk to you. And
nice talking to you.
Yeah. So there are a couple of questions I wanted to ask, and all of them are on a broader level, not particularly concerning hypothesis testing. One of the things being, often a lot of these hypothesis tests result in recommendations for decision making for the management. Aren't there some cases, I would guess, where a really big decision has to be made? In which case, is it advisable or is it the norm to conduct multiple tests in order to get more, conviction before that, advice is taken by the management?
Yes. So you could think of it as multiple tests or larger sampled tests, right? Instead of looking at it as multiple tests, you can say, I'm going to collect more data over longer periods of time. That's another way of thinking. And using more rigorous tests which satisfy the conditions that you have, not just using hypothesis testing, but also using confidence intervals. Use all the tools to just double check and triple check that what you're doing is sensible. I've been in instances where I would do 2-3 tests which fit a real world situation just to make sure that the p-values are sensible. And the moment you go to the management and say, boss, I was self-critical. I tried 3 or 4 tests. All tests are sensible in this case. Some non-parametric, some parametric, and all of them say, yes, we can go ahead.
Right. Okay.
So we have to use all these as tools or proof that, yes, this is sensible. Use all sorts of techniques, from confidence intervals to simple hypothesis testing techniques.
Yeah. Okay. Just on a similar vein, working in a paradigm where we have several rows of data and several columns of data on which we perform multiple operations to transform it, it sometimes becomes difficult to validate whether the results we are getting at every single step are exactly right, because sometimes it's not a very intuitive thing that we are doing, right? Because, for example, if we are doing a normal software development coding, for example, front end, we can see whether the output is coming correct or not. But when we have n rows of perhaps the data which might be abstract, we don't know that the transformation that we applied worked exactly the way that we wanted or not.
Because, for example, I would argue otherwise. I would argue that testing software is harder than testing machine learning models. And my
Yeah,
rationale behind
definitely.
it is,
Right.
sorry,
Yeah, it's
please go ahead.
different. I won't argue that it's harder in data. I would argue that it's different.
Yeah,
Right.
probably it's my bias that I've not done enough software testing, so I feel a little frightened by it. But in machine
Right.
learning, if you have large amounts of data with lots of columns and rows, you have all these techniques of feature importance, feature selection, even like rigorous econometric based techniques like Shapley values, like Lime, etc., which are model agnostic, which tells you what features are useful and what features are useless, right? So even if
Right.
you have very, very complex data, you can come up with statistical and econometric based guarantees that these features are really, really useful, the others are useless.
Yeah, that does make sense. But how about like just if in a day-to-day basis, if I'm coding and I just want to know that have some checks. For example, in software development, there is test-driven development where we have tests to check whether our output is correct or not. So to some extent, that can also be applied. That okay,
Yes,
I
yes.
know that So for one point, I'll check to ensure that okay, I expect this output. Is it coming
But
exactly that or not?
let me also warn you that sometimes surprises are abound
Yeah.
because if you're employing really, really innovative sources of data, you will find stuff that very few other people can think of. So there will be a lot of surprises, but lot of feature importance or data analysis conclusions are more or less intuitive, if not perfectly intuitive at the outset. They tend to be intuitive in general. Some of them are counterintuitive, but if you dig deeper and do the analysis, you can conclude that they're sensible.
Okay. Just one final small question, I guess. I'll wrap it up then. One of the videos, I'm in Applied AI, so I was looking through the videos, and in one of the videos, you said something that made a lot of sense. That when we get our data, often it will have some things that will not make sense, probably due to data entry error or something along the line that just went wrong. And including that data into our analysis can create major issues down the line. And you said that finding those errors is kind of an art, right? But also in art, there are heuristics that we can, perform. Like you use that, okay, the denominator should not be bigger than the numerator, right? So, are there any, heuristics that you
So
usually use that you could
simple
advise?
stuff like I would recommend you read data quality blog at Uber. They have a very nice system that they built. Similarly at Netflix. So simple analysis go a long way. There is also a research paper from Amazon Research in Berlin where they have written a system of doing simple data quality analysis using a spectrum of techniques, everything from simple if else conditions, like what you said, right? Denominator should not be zero, or all values should lie in this range, to doing time series analysis, time series forecasting to see, doing hypothesis testing using conglomerate-Smirnov tests. So you can do basic statistical checks on your data. I would recommend you to check out, just Google search for this. Just search for Amazon data quality framework or data quality and engineering. It's on Amazon.science. It's one of the really good systems I've seen. Similarly, you'll also find it on Uber's engineering blog. Similarly, on Netflix engineering blog. So just check these because they cover almost 90% of typical tests you should do.
Okay, so thanks a lot for
Thank you.
answering my questions so patiently. Okay.
Thank you. So, okay, folks. So, given that, okay, so let's wrap it up. It's already 6:30. I know all of us want to leave, take a break. So I'll wrap up today's session once again. Thank you for staying till the very end, and give us a day or so. We will start processing these videos. First and foremost, we'll send you the notes for all of these live sessions, all the notes that I have. Some of you have requested for additional resources for other tests. I'll add that. We'll send it to you by tomorrow, end of day. As far as video processing is concerned, we'll have to cut it, chop it, and process it. We'll start doing that tomorrow early in the morning because I think the team has to take a break anyway later in today. Thank you very much, and thanks a lot. We didn't expect this sort of huge presence, and thanks a ton. Thank you very much. Bye-bye.